How does laminar flow differ from turbulent flow? Imagine water flowing smoothly from a faucet or air gliding over an airplane wing. These are examples of how fluids move in different ways. Today, we are going to look at two main types of fluid flow, laminar and turbulent. Understanding these can help in designing better pipes, engines, and even medical devices. Laminar flow happens when fluid moves in neat, parallel layers. These layers slide past each other without mixing or creating chaos. Think of a calm river where water flows steadily without splashing or swirling. This type of flow usually occurs at low speeds or with fluids that are thick or sticky. It is common in small pipes or channels with smooth surfaces. Because the flow is so orderly, it uses less energy and causes less friction. The speed of the fluid is highest in the middle and drops to zero at the walls. This pattern is called a parabolic velocity profile. Turbulent flow is quite different. It is chaotic and unpredictable, with swirling eddies and rapid changes in speed and pressure. Imagine a fast-moving river with lots of splashes and whirlpools. This kind of flow happens at higher speeds or in larger pipes, especially if the pipe surface is rough or there are obstacles. When the flow becomes turbulent, it mixes layers of fluid together, which increases friction and energy loss. It is harder to predict and model because the movement is irregular and complex. The key to telling these two apart is the Reynolds number, a number that helps predict flow behavior. When the Reynolds number is less than about 2000, the flow tends to stay laminar. When it exceeds about 4000, turbulence usually takes over. Between these values, the flow can switch from one to the other. In practical terms, engineers prefer laminar flow when they need precise control, like in medical devices or delicate chemical processes. Turbulent flow is useful when mixing or heat transfer is needed, such as in engines or cooling systems. Knowing the difference helps in choosing the right pipe size, flow speed, and surface finish to make systems work efficiently. So, in simple words, laminar flow is smooth and orderly, with fluid particles moving in straight lines. Turbulent flow is rough and chaotic, with particles swirling and mixing. Both have their uses, but understanding which one is happening in a system is key to designing better fluid mechanics solutions.